Hello and welcome to the lecture on power MOSFET. So the main purpose of power MOSFET is it is used for switching purposes in high power applications. Hence it is an enhancement type. So based on that we can understand that for switching applications enhancement type MOSFETs are used. Like whether it is low power applications or high power applications, enhanced type MOSFET is used. But in case of high power applications, we have to go for power MOSFET to handle that high power. And so in electronic device MOSFET with that is low power MOSFET, in that case, the conducting N channel between drain and source gives large on-state resistance. So we have channel between drain and source that is responsible for high on-state resistance. So this leads to high power dissipation in the N channel in case of planar MOSFET. So planar MOSFET is nothing but the low power MOSFET. Hence, planar MOSFET construction is feasible only for low power applications because there we deal with low power, so the on-state resistance doesn't affect much. And so for high power MOSFET, the construction it is a vertically diffused structure and it is known as VDMOS. So vertically diffused metal oxide semiconductor structure it is, and so the power of MOSFET it actually consists of parallel connection of thousands of basic MOSFET cells on the same single chip depending on the power or current rating. So we have actually here we contain lot of basic MOSFET cells. These are connected parallelly to handle the high power based on the power or current rating. The uh, the cells are connected on the single chip. Now here like a planar MOSFET, power MOSFET is also a unipolar device. So the conduction is only due to majority carriers. And in case of power MOSFET during turn-on process, the the time delays caused due to the removal of minority carriers are eliminated. So the switching speed is very high or switching time is low because there are no, it is not a bipolar device, so there are no minority carriers. Hence, the turn-off process delays are reduced in case of MOSFETs. Now, hence, MOSFET it has a higher switching speed. It has higher switching speed compared to power BJT and IGBT. Because power BJT and IGBT, their conduction, those are both are bipolar devices. In that case, conduction is due to both majority and minority carriers. Whereas um in MOSFET, it is only due to majority carrier. Now, power MOSFET it can be operated up to 1 megahertz. As we are reducing the turn off time, the frequency can be as high as 1 megahertz. Whereas for IGBT, it is 50 kilohertz, power BJT 10 kilohertz, and SCR 500 hertz. So these are all bipolar devices, whereas MOSFET is a unipolar device. Now we can see the structure of our MOSFET. This is called vertically diffused. Here we have N plus and N minus P, N minus and again N plus. So here we have a N minus layer. This layer is going to support the voltage blocking capability. So the device is constructed such that it will handle high power. So here N minus represents the N layer is lightly doped, whereas N plus represents the N layer is highly doped, and here also it is N plus which is highly doped, whereas here P there is nothing written in the suffix as the plus or minus, so it is moderately doped. So basically here minus and plus are to signify to specifically say that they are highly or lightly doped. Now the thickness of N minus layer, this determines the blocking capability when the switch is off. So when the device is off, the voltage appears across the device. So at that time, how much voltage it can sustain or how much voltage it can be applied during off, that is determined by the thickness of n minus layer. And in this, you can see a parasitic NPN BJT transistor like this, N plus PN minus. And there is also a parasitic diode PN, uh, and power MOSFETs are available with ratings like 500 volt and 140 ampere. So this is all about power MOSFET. Thanks for watching this video, and please subscribe my channel to get more videos.